Good morning, everyone. Thanks for your patience. As usual, everything's happening right at the last minute. I'm still getting email presentations and everything through. So if you can just bear with us for a little while longer, our team presentations will definitely start at 10 a.m. I just want to make sure that everyone is teed up, that our judges are all ready watching the live stream. We've got all the presentations in and all the tech is checking out. Just a reminder, we'll have 4 presentations. The running order is in the stream notice. We'll be starting with Curio. So each team will be presenting for 5 minutes, and then there'll be 5 minutes of Q&A. If you've got any questions for our teams, then you can ask them via the Veto Hub. We'll be prioritizing questions from our judges, of course, but anyone is free to weigh in with a question. And also to say that there'll be one team member from each team presenting, but if anyone else from the team wants to weigh in with a response to a question, then you can do that through the hub. Also to emphasize, I know I need to update some of the team descriptions on the hub. I'll do that as soon as I can this morning. But each of the teams have a dedicated page on the hub. And if you want to contact any of the teams, you can do that through the hub. The team members and their usernames are all listed at the foot of their team page. So you see that on the left-hand side at the bottom. So bear with us just a little while longer. We still, even despite kicking off a little bit later, even if we're starting at 10 a.m., I would expect that our presentations will be complete by 11 a.m. We will have, there'll be a bit of an interlude, but what we'll be going back to our model team to see how they've been progressing through the week. So you'll get a bit of an update from them around 11 o'clock, and then we'll find out around, hopefully no later than 20 past 11, who the winner is of the Robotics and Care Mashup. But we're just going to progress through everything basically as quickly as we can. So we may be finished earlier. I just want to allow time for any kind of technical hitches and stuff. As with every hackathon, it's all a bit rough and ready, but it's a lot of fun. I want to say good luck to everyone who's going to be presenting. A huge thanks to everyone for contributing. Huge thanks to our mentors, to our sponsors, Jill, who've been mentoring our teams throughout the week, for the support we've had from the Usher Institute, and of course our partners at the Robotarium. It's been a fantastic 5 days. This has been a big experiment for us in terms of running our first virtual event. And what better place in a robotics test bed as well. So it's been absolutely fantastic. You'll hear later on from Mauro. He's not here with me right now because he's furiously working away on finishing up some robotics integration with the model team. So everything's going right down to the wire as normal. But it will be a great show for you this morning. And as I said, best of luck with everyone. I'll be back with Curio, hopefully no later than 10 a.m. We'll be kicking off, and then we'll rattle through the 14 presentations. If anyone's got any questions, feel free to ask them in the live stream discussion. If you're in a team and you're confused or need any technical help, you can ask it in the green room in the private chat. I would ask, if you're not presenting and you're not waiting for the previous team's Q&A, not to be in the green room, just so we can reduce the pressure on everyone's laptops a wee bit. It's a bit processor intensive. Otherwise, if you need any other technical support, you can just email events@productforge.io. Just be aware, doing my usual this morning, I am both hosting at the moment and also trying to manage the live stream and keep an eye on the team's emails coming through. So apologies if I'm seem a bit scatterbrained, but we'll get through it all this morning. So thanks very much. I'll be back with you shortly, and once again, good luck everyone. Hi, folks. We're just about to get going. So I just want to reiterate once again, thanks very much, everyone, for tuning in this morning to watch our team presentations. I want to say thanks to everyone for participating this week. I am joined here with Raken Sada for our first presentation from Team Curio. So take it away, Raken. Hi, Rakan. I'm so sorry to interrupt you. I think we've got a wee bit of an audio glitch. Just give me 1 second if you can go back to the title slide. I'm really sorry about that. Just one moment. Okay. Okay. Hi, folks. Apologies again to Rakan. I'm so sorry about that. Audio issue glitch should be fixed. Just to double check 100% before you fire into your presentation, do you want to just say hello, just to make sure that I hear a big hello from the other end?
Hello. Hello. Can you hear? Hello.
Yeah, I think we're good.
Okay, great.
Okay, so thanks. Good luck. Take it away again.
Okay. Thank you, Alan, again. Hello, everyone. Good morning to today's concept pitch presentation. My name is Mohammad Rakin Shardar, and I'm going to present our project Curio. So our team member comprises of myself, MD Rakin Shardar, Professor Mary Stewart, and Shang Huang from Heraquat University. So the story or the main concept idea came from the fact that various medical treatments requires patients to follow specific guidelines and rehabilitation process for the recovery. But patients prefer to follow this recovery process in their homes because obviously they feel comfortable there. Generally, this recovery process includes routine checkups with the physicians, taking regular medicine, limiting physical activities. However, a patient who is an older adult, it's quite challenging for them to remember and follow these specific guidelines during the recovery process. And traveling for them and also for a person who is disabled is quite challenging for routine checkups. And it can be even more challenging if the hospital is located at a far distance away from their home. So one of the solutions to this can be in-home nursing facility, but in-home nursing facility is not accessible for everyone within their budget because according to some data, in-home nursing can cost up to £4,584 per month, while residential care home can cost up to £3,250 per month. So the idea came from these problem statements about our Curio is that to propose robotic nursing as a service, which provides a post-discharge robotic nursing subscription service on behalf of clinicians and care professionals. The whole model consists of an intelligent social telepresence robot equipped with a certain set of telemedicine equipments, which will accompany the patients when he or she is discharged from the hospital, and a cloud teleconsultation and healthcare management application, which will integrate the clinicians and care providers to the whole care ecosystem for the post-discharge recovery service. So the core features of Curio is obviously provide remote consultation to their patients by the clinicians, and patients can also access their clinicians as well easily, allow routine checkups on their patients for the clinicians, and they can also monitor their health and well-being using different telemedicine sensors, which will be integrated to the robot's body, and they will be connected to the cloud, so the data stream will be real-time, and also support robot-based emotional and cognitive coaching to the patients. So the advantages of using Curio will be subsidizing the in-home nursing care at a much lower cost, enhanced collection and monitoring of patients' vital point data without the need of any kind of physical contact, enhanced communication due to the robot's physical appealing and presence, and it will be an enhanced telepresence service, reducing social isolation, and provide in-home routine checkup facility. So far in this hackathon, we have designed a Curio robot nursing as a service cloud application. We have designed the user interface and a functionality for teleconferencing through the robot, as you can see in the picture. And we also have designed a no-contact pulse measuring sensor, which has been integrated to the robot to collect heartbeat pulses. So our primary selling channels or our subscription channels will be work on two model, and one is the software subscription and is a post pre-programmed robot or software subscription. We will also work on a partnership with SoftBrand Robotics to distribute the license through their channel as well. So now we want to show a pitch video for our presentation. Alan, if you could take over now.
I forgot. It's time to measure Morris pulses.
Hi.
Hi, Meguro. Can you spare 15 seconds so that I can take your pulse reading?
Sure.
Thank you. Please try not to move. Thank you for your patience. It seems that you have a bit high pulse rate today. Perhaps you should take some rest. Dr. Wald will consult with you tomorrow.
Thank you very much.
Hi, so thanks very much for that, and apologies again for the issues with our audio. No matter how much testing you do, if you try and do too many things at once, it's going to go wrong. I'd like to open things up now for questions. So you can drop your questions into the discussion on the event live stream. So I'm just going to give it a couple of minutes to catch up. So I'm just going to, while we're waiting for the stream to catch up. So what are your future plans with this?
My future plans is to actually design the complete financial model of the whole solution, because so far we have proposed a subscription-based service, but obviously we need to construct a concrete financial model based on the subscription model, and also we need to validate the concept based on some after publishing some surveys, conducting some researches on this. And we also plan to launch this in a very small targeted market to actually see how it actually performs in a live action setting. And after collecting some data, and then we will think about launching it big. So that's the plan.
Okay.
Yeah.
Great. So we have a question from Michael from the Usher Institute. He's one of our judges today. The emotional and cognitive coaching element seems like a key feature. Any more information on this development?
I'm sorry, can you repeat it again?
Sure. So this is from Michael at the Usher Institute. He's one of our judges today. He's asking, the emotional and cognitive coaching element seems like a key feature. Any more information on this development?
Basically, we have found some studies which have been working on providing cognitive coaching or therapeutic session using robots. So this is one of the features we plan to implement, but during the development of our minimal viable product for this hackathon, we could not implement because it takes some time to do these studies. But obviously, this is something we definitely want to implement.
Okay. A question from Chow from DHI, again, one of our judges this morning. He's asking, can you describe how you handle privacy, both technically and in terms of people feeling comfortable with the robot in their home?
Currently, our solution is deployed in a cloud service application. So for the teleconsultation session, what we are doing is we are actually using a P2P video conferencing channel. So it's peer-to-peer. Both ends are encrypted. So there are no third parties which is actually providing the service for the teleconsultation. So that's one of the security issues we have considered. Another issue which we have also obviously considered about the client security for when the doctor is actually visiting the page. So all the data is encrypted on the client side, and of course, as well as the robot side when the data is transferred from robot to the cloud.
Okay, great. One more question. How would you? So this is from Mathini. How would you make sure safety? How would you ensure safety and avoid any unexpected accidents?
This is one of the risk assumptions which we have made in this project, because obviously once we are deploying a robot to a new location, basically our patient's house, the robot needs to actually learn the environment around it. So this is one of the risk assumptions which we have made, and we are actually working on some technologies which we can implement to actually consider this fact very seriously, so that any kind of scaring movements which the robot makes, the patients, they do not actually feel intimidated by that.
Great. Okay, thanks very much. I just want to give it one last moment, just in case we've got any other questions come through. There's a wee bit of a delay on the live stream, so just another couple of minutes, potentially. Okay, I think that's everything. So obviously, just to reiterate, all of our teams have a page on the Veto Hub, and you can see the team members, and you can, if you want to comment on their page, or to be honest, comment anywhere in the discussion, and you at them, they'll get a notification, so you can follow up with anything afterwards. Or actually, we've just got one other question come through here, so just one more. Could you comment on the cost of transporting training? I should read this in full before I start reading. Can you comment on the cost of transporting and training in the home and maintaining robots if something were to happen? Also, is there a plan to train patients who have not been socialized with robots?
That is actually one of the parts of our future plans, which I have just discussed with Alan just now, because this is one of the key considerations in our future plan, to actually study and take some user feedbacks from our solution from actual users, because this getting adapted to a robotic technology around the house, who will be with them 24/7, it might not be quite comfortable, so it might need some kind of adaptability from the patient side, but obviously we cannot assume the adaptability from patient side. It's them who would actually choose to actually like it or not. So that is one of the key studies we consider to do right now.
Okay, well, thanks so much. Great presentation. I'm just going to cut back now just to the stream schedule just for a few moments while we get our next team up. Our next team is Hive RoboCare. So if you make sure that you're ready in the green room just now, and we'll be back on in hopefully just a minute or two. Thanks very much. Welcome back. I'm here with Jawad Hussain with his project Hive Bot Care. Take it away, Jawad.
Okay, hello everyone. I'm Jawad Hussain. Me and my teammate Imran Huma have been working this week to create the Hive Bot Care system. So what is the Hive Bot Care system? So it's a system of three pre-existing social robots. So we have the assistant on the left, the companion, and the rovers, which I call them. So each of these attempts to address an issue in healthcare, and especially in healthcare of elderly people. So I'll get in more into that later. So firstly, the three issues that they would need to address are cognitive decline, loneliness, and injury. So cognitive decline includes anything, any loss of cognitive ability. So you find that your memory declines with age. You're not as good at maths, things like that. So this affects a huge amount of people, and obviously as medicine advances, more and more people will be affected by this. So I have a huge statistic here of 1 in 9. This isn't representative though of actual cognitive decline, because subjective cognitive decline means that these are people reporting that they have noticed change in themselves. So the next issue is loneliness. And a huge number of people over 65 are socially isolated, which means that they really don't have a lot of social interaction, and so they're quite prone to loneliness, especially after the age of 65. Another huge issue with elderly people face is injuries from falling. So I have a statistic here. In 2017 alone, there was 200,000 hospital admissions just from people who have fallen over. So what is the solution to this? So as I said, Hive Robot Care is a system of three assistive robots, or three social robots, that would each address one issue. So on the left we have our assistant, who would address cognitive decline by playing cognitive games. So things like challenging games, so things like a fun way to say what's 9 plus 10, what's 20 times 3, stuff like that, and memory games, stuff like this. And then we have a companion in the middle, and this is a pet-like robot. Some of you might be familiar with the Para robot. So this would be something that the user would stroke and interact with. And then we have the rovers. These don't actually need to be a social robot, so they don't need to communicate at all, but these would patrol corridors and hallways and make sure that nobody has fallen. And they wouldn't prevent any injury, but they would really help to make sure that people aren't stranded, so they're injured and they have no one to help them. So the most important part of our system isn't each individual robot, but it's the fact that they work together, and because they work together, they're able to create a data profile of a user, which is to essentially monitor how they get on, make sure that they're happy. So we see here that there's software to be able to detect a user's emotions from a camera feed, and then we make a profile of that, and we say this user is happy most of the time. Maybe they don't need so much time with the companion robot. But if the user's angry most of the time or sad, we can have the system ask, how are you? Are you okay? And if the system feels like it's necessary, they will spend more time with the companion robot, or if it's severe, a carer will be contacted. So why would you bother using Hive Robot Care when you can just get any single one of these robots? So the first question would be, who are the competitors? Why would you get this if you could just get something else? So there isn't any system of robots for healthcare. So there is healthcare robots that act individually, like the robot I showed you at the beginning, Curio robot. This robot is deployed in some situations, but there's no system of robots that work together. There is something called eWare and eHealth, which is one social robot plus some sensors that tries to track a user's data profile as well. And then they also try to change their system according to the data, but they don't actually have any practical functionality. It's just things like pill reminders and stuff. Whereas we have a robot that you can send in to abate loneliness. So a huge thing with the system is that it can adapt to a user's needs. So obviously, as you age, things change even more. So this system can create a user data profile and keep it updated to where that we understand this user is deteriorating in their mood. So we need to send in the robot more, or maybe we need to take new precautions. Another important thing the system does is it can learn from other users. So we can make a data profile of the average 70-year-old in a care home with X and Y impairments, and then we can just say we have a new person here with similar profile. Let's try this same thing. And also is the scalability, where having lots of smaller, cheaper robots is more viable for a large amount of people than having one robot that keeps moving. So just quickly, some assumptions we have to make and how we address them. So is a system of robots intrusive? Would someone mind having like 10 different robots running around and being aware that these robots are collecting their data? So the literature would suggest that it's okay, that people are more concerned about the price rather than the privacy, according to a study by Padwell and al. And another assumption we made was, so obviously the focus of our system is the data collection and the teamwork between the robots. So would they just prefer cameras instead of little rovers and stuff? So the views on this are conflicting. It's hard to say if people would prefer to be watched by cameras or if they prefer to be watched by a cute little robot. Yeah, that's all I have for you. So thank you for listening.
Thanks very much, Jawad. Great presentation. I'd just like to open it up now for questions from the community, just to allow the stream to catch up. So for you, how would you like to take things forward after this?
So the first thing I want to do is validate the system. So the literature is all about single social robots, and it doesn't really look at what a system of robots could do. So definitely validation is hugely important. We need to, like our assumptions, we need to confirm that the assumptions made on single social robots apply to a system, and also if elderly people even want a system of robots in the first place. But I mean, the literature shows hopeful results so far.
I very much like whenever people bring up the word assumption. That what a lot of all of this is about going in and doing that research to make sure that we're on solid ground with our proposals. We've got a question here from Robert from Shill, one of the judges today. Is there a danger that those with cognitive decline might be confused or distressed by the presence of these robots? Could this be a barrier to uptake?
Yeah, so that is, a great question. So, yeah, I mean, it can be an issue. So the biggest thing would be to have a robot that is happy to be, I would say, abused in the sense that, like you'll be touched, it might be hit or something. But also we have, because of the emotional tracking, the robot, would know if the user's getting riled up. To say so we could have some precautions against that, but more so we could just have monitoring from a caretaker as well, which is important, because we don't want to replace caretakers at all. We would definitely want this to be a tool that they could use. So I would say it wouldn't be a barrier, but it definitely have to be a consideration. Yeah, I think there's methods to deal with it.
Okay, great. Now I just want to allow a little more time for questions to come through. I did notice, just to mention, someone earlier, I think this was talking towards the previous presentation, but mentioning about the business model canvas. So all of the teams who participated this week have filled out, it's kind of a variation on the business model canvas. It was actually a variation on the lean canvas. We have a sort of a product forge canvas that covers a whole range of things from customer, users, beneficiaries, and all these kind of things, routes to market. All of the teams have submitted them. We have, for Xiao, not a question, but just a thought. If you're looking beyond one robot, you could look beyond robots altogether. What's the effect of some ambient sensors combined with robots, i.e. can the robots be more specialized, lighter, cheaper, if they don't have to do everything? Not a specific question in there, but any thoughts you might have on that?
That's definitely a question for an electronic engineer. I wouldn't know anything about how to make a sensor cheaper, but it is definitely a good consideration. Why make a robot cheaper if you could use something that is designed to be cheap in the first place? But yeah, I mean, the social aspect of our system is hugely important, so we couldn't ditch the robots.
Okay. Michael from the Usher Institute, again, one of our judges today, is asking, have you thought about options to combine social and companion features in a single unit rather than link multiple units?
Yeah, so I did kind of mention about it. I think I was too brief. So with our system, you can see that we have Myro as our rover. So he's a social robot, so it's kind of a waste to use him only to have him walk around a corridor. So the reason for it is because if we want to advance the system, we could remove a lot of functionality. So the rover would be just a really cheap robot with a camera or a depth sensor or something like that that would run, and that would save cost of the system overall. So so we could have more rovers for cheaper instead of having if we have everything in one robot and then you want to scale that up. So I have a care home of 20 people. One robot's not going to cover 5 people, so I need 5 of those robots. And that robot can't, if I want them to keep walking around checking, make sure no one's hurt. So yeah, I think it's cheaper to have less sensors, a simpler robot that is controlled by a smarter robot.
Okay. Okay. Thanks very much, Jawad. Fantastic. And again, if anyone wants to follow up with additional questions, you can at the team on the hub. They've got the profile page set up there. And we're just going to break back to the stream notice while our next team, Fall Detectives with Tumble Sense, sets up. So thanks again, and we'll be back in just a couple of minutes.
Hi. So,
hang on.
Okay.
I need to introduce you first. Welcome back, everyone. Apologies, we just had to switch around the order of the teams. So, if you're watching, could we get Marta? We need Fall Detectives Tumblesense to be joining the green room during the Q&A for this presentation. If you're listening just now, so we switched things around. Next up, we're going to have Communicare Hermes. So presenting will be Dr. Mel McKendrick. Take it away, Mel.
Okay, hi. So, hello and welcome to Communicare's Holistic Messenger to enhance social support. Okay, so imagine that you've been isolated for a period of time. You may be elderly, you may have a mental or physical disability, or live in a rural area. You're desperate for some social contact and are becoming more depressed with the weeks. You hear of a befriending network and sign up. Fantastic. You can't attend in person though. Telephone befriending may seem a little impersonal, so you're thrilled to be offered an online befriending session, and now it's your first session. You have no idea what to talk about, and the befriender seems to be straining to understand your accent. You start to feel stressed, and the conversation becomes awkward. How are you feeling about seeing this person again next week? Maybe you'll just leave it, and then you'll stay in the cycle of being isolated. Hermes provides a holistic, low-cost and highly accessible solution to measure non-verbal and verbal online social interaction. By doing so, it can provide real-time feedback to guide the befriender to respond to specific needs of the recipient by suggesting the emotional state that the recipient may be experiencing and suggesting conversational topics that may be useful to pursue. This will help the recipient to be put at ease and help the flow of the conversation and enhance the general experience. Over time, it may help to train the befrienders to develop a more empathic response without having to rely on prompts. The Communicare team is drawn from a wide interdisciplinary mix of psychology, multilingualism, communication, engineering, and mathematics. So we have the right mix of skills to bring the product to fruition. The technology utilizes a simple webcam with our Hermes software to extrapolate feature recognition and align interpretation with regional accents to enable a more relaxed dialogue and suggest when the recipient might be feeling stressed so that the prompter can suggest a change in conversation perhaps, or some helpful topics. We can detect, let's see if I can just play this. We can detect signs of stress through skin color changes and heart rate, as well as a series of verbal and non-verbal indicators, including how we use our eyes, where we're looking, pauses, silences in conversation, hesitations, various different body language and gestures. And we're providing a full package then of verbal and non-verbal communicators to indicate how the person's feeling and to help that transition move smoothly. Okay, so we'll talk about the technology next. So in terms of the markets and where that technology can be applied, we know that in the healthcare market, for example, there's been some preliminary work looking at the cost of befriending in terms of the cost reductions, really. And we know that it's estimated that just in healthcare, that can save the NHS around £500,000 a year to provide befrienders. But that's only looking at a small aspect of this. So if you think about in terms of the labour market for the reduction in costs of absenteeism and presenteeism, and in education skills training for things like student retention. Sorry, I'm hearing some
I'm so
audio.
sorry. Apologies. Right, I think that's the issue. Sorry about that.
That's okay. Okay, I'll just carry on. Okay, so as I was saying, absenteeism, presenteeism, and we can also in education skills training sector, for example, around a third of medical trainees experience depression, and it costs about £200,000 to train one of these. So retention is important in terms of cost savings as well. But more importantly, there's the experience of the users and how this is going to help them. This is a digital solution so that it can be used in person, so human to human befriending, but it could also be used because the manpower of befrienders is limited. It can also be used in virtual reality solutions, for example, virtual reality befrienders, and also robot befrienders. The actual technology itself can be applied across all of those contexts, which makes it have a really wide application. In terms of the competitors, we know that there's a certain amount of face detection and analyzers out there in the market, but they tend to be built around a more generic case rather than being data driven with personal use cases. So we're building up a profile that can give a more personalized approach here. In terms of the risks, then, we believe that the risks and the ethics operate together in some senses. So we've got technical risks, for example, capturing the eye-to-eye contact, where people are maybe looking in different locations and different angles on a computer screen. We'll be able to capture various different types of eye movements, like blink and attentional shifts, that are not necessarily locked to direct contact in that way, to mitigate against some of those risks. And we also will integrate the different signals coming in so that we can mitigate against the risk of events happening at different times. But there's also operational risks. So we need to consider how the users will accept the solution, how they would feel about being evaluated in some senses. They may perceive that, and looking at things like data protection. So ways of mitigating this we've looked at is a participatory research design, where we actually have users, befriendees and befrienders involved in the design process directly. And also collecting the data live streams so that it doesn't actually have to be recorded. We don't have to record and store video data and audio data. All the signatures will be picked up live so that you're not actually storing people's personal data in that way. And one of the first things that we want to look at is market research, do some market research before developing the prototype, and then leading up to that participatory design before then going on to the product development and testing. And the other thing to mitigate against is not having enough of an intelligent solution in terms of the training data. So we're going to add to that over time as we commercialize. So that brings us to the end of the presentation, really. But what we want to have is some asks in there, and our three main asks then would be to give us some help with funding this proposal, to look at some advice for the regulatory aspects as well in terms of recording this data, and also just help with the general business plan. That's really the main things that we'd be interested in taking forward. Okay.
Okay, thanks very much, Mel. Apologies for the audio interruption in the middle there.
No problem.
But you dealt with that very gracefully. I'll just like to open the floor up now to questions, and I'll just give the live stream a couple of moments to catch up. If anyone's got any questions for Mel. you can just ask them there in the discussion of the event live stream. So Michael from the Astro Institute, again, just a reminder, I'll say this every time, just so you know when it's a judge or anyone else. Michael's one of our judges today. Is the Hermes software already developed?
So the Hermes software is partially developed. So it's, some of our team have developed some of the metrics to be able to measure facial characteristics, facial expressions, eye movements, etc. And we know that there are some already developed skin color change and heart rate detectors using webcams as well. So some of this technology is developed, which means it makes it a bit easier. We're not completely starting from scratch, but the product itself is not developed, the end product.
Okay. Chow from DHI, again, one of our judges today, says, sorry, I may have missed this, but how do we determine what stressed is? I.e., is it a benchmark or personalized?
Yeah, so this is where we have to do a lot of user testing, and we pair subjective stress responses with objective data, and that's going to be the greatest challenge, is building up the training data so that we understand when people are stressed and we can detect that. And we've already started working on, across a number of projects, on coding schemes to be able to do that.
Okay, great. Okay, sorry, I'm just awkward pauses. I just want to make sure that we've got all the questions. Mm-hmm. Again, just I'll keep reminding everyone of this. All of the teams have a profile page set up on the hub, so you'll be able to connect with Mel and the rest of the team members any point after the presentation if you've got any questions or feedback or anything. Just a follow-up from Chow. He said, and then can you baseline with people via normal conversations and then personalize findings for them over time?
Yeah, So what we'll expect to find is that we would have some group characteristics, but then there may be some personal individual differences there as well that we'll be able to do both of those things, benchmarked and personalized.
Okay. No. Shall again, i.e., what's exceptional for me, not to a general population?
So there will always be anomalies, like in any kind of artificial intelligence algorithm, there'll be an anomaly occasionally. But if we collect enough data on this, enough training data, we should be able to cover most typical aspects that would differ across people, really.
Okay. I don't know. There'll be more from Chow. He needs an ends at the end of his last question. I think that might be everything. You've clearly fired up his imagination, his stream of consciousness here. Okay, I think that's all. Again, just to reiterate, people can follow up with questions. Done from Chow. Well, that's it. Thanks very much. So thanks so much, Mao. Apologies again for the audio interruption. We'll be just taking a quick break back to the notice as we tee up our final presentation. So we just switched around the running order there. So it will be fall detection coming up next. Okay, back with everyone in a moment. Thanks very much.
Thanks.
Hi, folks. Sorry. So we are running just a few minutes late, and if you're just looking at the schedule there, we've just switched up the running order for the last two presentations. But this is our final presentation of today. We will be hearing from the model team after this. They'll provide an update while the judges are deliberating with all of the things that they've been hacking together this week. So I would just like to hand over now to Marta Vallejo with Full Detectives Tumble Sense. Take it away, Marta.
Thank you very much. Thank you for stay here to listen to my talk. Yeah, I'm going to present the Tumble Sense. We try to reduce false alarms in fault detection, and our team is fault detectives. That is me, Petros, Brian, and Tony. The problem that we have identified is the false. The false, according to the World Health Organization, can be fatal, and more than 500,000 of false globally per year are mortal. And this is a real problem for elderly people. People over 60 will really suffer a highest number of them. It's so that over 10 or 20% of elderly people suffer recurrent falls. We are aware that there are different detector systems in the market which suffer from different type of deficiencies. But what we focus here is in the high rate of false alarms that this system has. This caused that the several issues, not only the economic burden of dealing with false alarms, but also in the stress and anxiety of the person and the carer if it's in the other side of the alarm, and also in the lack of trust that this can carry out, which means that perhaps the user even stop using this kind of devices. To try to increase the robustness and decrease the level of false alarms, what we have tried we thought is to use different sensors together to combine these kind of signals. The idea is to have a traditional, starting with a traditional wearable system that will be connected to the stationary robot. The wearable will gather some data from the user that will be sent to this kind of receiver, and the receiver will have some kind of way of directly interacting with the user. This direct interaction with voice will allow to confirm if something has happened in the case of an alarm has raised. The fact that this receiver is able to confirm by answering, by questioning, "Are you okay?" to the user, will as such decrease the level, the number of false alarms. In the case that the answer is not appropriate or there is no answer, alarm will be raised. And our idea is not only to erase this alarm, as it already happened, but also to collect some wearable and sensor data, audio data, to send to the carer of the community alarm system. This as I show you here in this schematic, will in a way inform the decisions. Then you can see here that our system is divided into three parts. One is the user with the fault detector that will be able to communicate with the central system. Central system will be able to collect information from not only the sensor, but the idea is to be able to extend this to perhaps other sensors that exist in the house, and to collect this information and send to the person in charge of the alert. The idea is not that we don't really want to keep storing the information all the time to avoid any personal information issue, but only to keep temporarily this data only in the case that the alarm is raised. For that, we all have a proof of concept that Tony, our inventor engineer, has provided for us. Unfortunately, I'm not going to be able to give you many details about this, but what you can see here is 2 elements. First is the accelerometer, and the second one is this kind of system that will be able to record without storing properly these segments of time or of audio that will be we will be able to send to the alert, to the person in charge of the alert system. The idea is to create a system that is very low cost. We are thinking in something around 200 pounds. And this will allow not only that the home to sell it to home associations, but also to personal to final users. Well, our roadmap, I think I'm being very fast, sorry. Our roadmap is like, first of all, to create proof of concept, a technical prototype that in a way we will be able to show. And this proof of concept will allow us to record some kind of feedback with the use of some kind of focus group and to do other market research. We also could have the idea that our system could be integrated in other ones, so in a way only offering the idea of the robot and the recording of the sound. It doesn't need to the accelerometer be also included. And well, once that we have this feedback and perhaps on a small investment at the beginning, we will have to we will be able to create our minimum viable product, which will also go through multiple rounds of pitching for investment to be able to finally have a final product. This final product will not be able only to have a nice product, but also to be safe and regulated. We also consider that we will have a second roadmap in order to have funding for research. This roadmap will be more from the academical perspective, where we are very interested in creating a system that can be joined to the one I explained here, to be able to include something that prevent falls in case of we are interested in dementia and also in the area of Parkinson's disease. And what is the impact that a system, as I explained, will have? Well, as I mentioned before, there are different ones. First is to avoid all the resources that I spend when alarm is raised. This will save money to these home associations, and in the case that we will be able to sell to the NHS also too. And also to decrease the level of anxiety and the stress of this kind of situations. If you have a system that is able to interact with you and ask you if you are okay, and this reduce a percentage of the times the alarm is raised, this means that the person at the other side, that if imagine that is a familiar, will be less worried because less times this is going to happen. Also, the stress and the anxiety from the user, and also the trust on this kind of systems, that in a way we expect that the user will continue more the use because of that. And also the fact that these alarms are in a way surrounded with some kind of context will not only be able to raise the alarm, but also to see if there are more urgency in alarm than others, which means that in the case that the alarm is important, we could reduce a long period of lives. Yes, and the risks that we have in a way identified are mostly in the part of the ethical issue that comes from the storing of information. Even if our store of information is not permanent, that we don't plan to send it to any cloud system or anything like that, will be totally local to this kind of robot. We still have some kind of privacy issues, and for this we will need to be very transparent to the user about what we do with the data. We are aware that we will have to have some informed consent for the audio and how we send this information and to who. Also, if we, in a way, in the future, we thought in including other type of media, for example, images collected from this robot or other type of sensors that could exist in the house, we also need this kind of informed consent. And well, that's all. This is our team. It's Brian, that is a PhD student in neuroscience and AI. Me, that I'm a lecturer at Harvard University, focusing machine learning. Our software developer, Petros, and our wonderful engineer and inventor, Tony. Thank you very much. I'm happy to answer any question. If not, I think Tony should be able to answer also.
Okay, thanks very much, Marta. Thanks. So we're just going to open it up to questions on the live stream. Oh, already got some questions. So. Matheny, I think that's. Is there any way to predict fall, detect before falling?
Before.
Yeah.
We don't. We are focusing in only the alert part because this is something easy to bring to the market. But yes, there are ways of detecting falls, and the idea is that we will investigate on that. This is something very personal to the person. Then, in a way, what it would happen is that we will have to collect, in this case, information to have some kind of machine learning model behind that is trained with the data of the user, and also to use other type of data that has been collected before. But yes, this is something like a second part, as I said, that comes from this kind of second line of research.
Okay, great. Shal from DHI is saying, have you undertaken some initial desk research around existing falls detection products? This is a busy market with lots of products already available. Agree with Matheny, pure fall detection is relatively common already. Adding context to the alarm call is good. But if you have that context, you could be able to raise risk flags leading up to a fall. So the question that was a kind of a double barrel one, but have you undertaken some initial desk research around existing falls detection products?
Yeah, we collect some data. As I said, we don't have any innovation in the part of the falling, and the only thing is like we expect to have our own system because we want to do something low cost. But the idea is that this can be integrated in others and only provide what is the support for the false alarms.
Okay. Michael from the National Institute, sorry, I meant to be flagging. So Charles, obviously one of our judges today, and so is Michael. Michael's asking, just to confirm, is the product development focused on the static response relay robot or the wearable or both?
Okay, as I said, the wearable will not have at the beginning anything that is innovative, and our only goal is to have something low cost. If we will, for example, buy an external product, this means that the cost of our product will be higher. Our idea, our more intention is to, in a way, to create this kind of system that allowed the interaction with the user. To avoid the false alarms and to connection to the alarm system, giving this kind of context. This started with the idea of the preventative aspect, but we consider that this will require more extensive research and funding, and this is why we want first to have this part and later use all the system to be able to include more functionalities.
Okay, great. I just want to give it 1 second just in case there's any other questions. It's not a question on your teammate, Tony. So great talk, Marta.
Thank you.
We should have had more teammates rooting for each other in the comments here. Well done, Tony. Okay. So thanks very much, Marta. I think we'll break to back to stream notice again. So just a reminder about what's going to happen next. Our judges will deliberate in private. If judges, if you're watching this still, I'll be joining you in the room there shortly. I just want to tee up the next session. For those watching the live stream, while you're waiting for the results of the event, we'll be hearing an update from the EOSwitch team. They've been hacking away on new integrations all the way through the week, so they'll be showcasing what they've come up with, and then we'll come back. Sorry, we might not hit our target of 11:30, but we'll come back as soon as possible with the results of the judges' deliberation. So thanks again to all of our speakers, all of our teams, and join us back soon. Thanks very much.
Fantastic, those presentations. I'm glad I'm not presenting. I have pitched before, and I thought I didn't have to pitch today, so thank you very much, Alan, not making me do that. So I started to do some PowerPoints last night, and just to sort of go through where we're up to. We were, lucky that we had time beforehand to just so that if we were supposed to be the model team, to actually come up with some, hopefully some reasonable suggestions before we got here. So if I can bring up a bit of a PowerPoint. It's not coming
far
up.
Far right one.
All right, okay, fine. Good job, I've got someone who knows the technology here, so still not coming up. Is that not coming up? Okay, fine. So if we switch to, as a lot of you will already know, I've bored you enough. The ear switch for this hackathon this week has been looking at how we take the ear switch, which has already got a proven prototype and proof of concept, and how we actually integrate that with the environmental controls that are available. So that's what we've been working together. So with Thomas and Maro from the Centre of Robotics here, and with Nick Lane from Function Control, and using Tekla and Grid 3, which are one hardware interface and one software interface for assisted technologies. The problem is that some people with severe neurological conditions are unable to control their own environments. And existing technologies have their limitations. So we were trying to see whether we could link earswitch to existing dedicated assistive smart home interfaces. And what we've done is we've demonstrated communication and control of smart homes for people with limited or no movement. So as we've shown before, just for those people who don't know, the ear switch is basically a camera in an ear mold, and it helps operate assisted technology by acting as a simple switch. So you see the eardrum there on the left, and as it moves, is picked up by the keyboard. So within our project, the things that we have achieved, and we'll go through them in a second with the demonstration, is that Thomas very clearly has made a very good plug-and-play software. Basically, hopefully I can show that without causing too much problem later on, where it picks up the movement. So there's no configuration needed. It just, I put the ear switch in my ear and it works. So that's been extremely successful. So even if we'd just done that, that'd be fantastic. We've used that to integrate with the graphical user interface. So that's Grid 3 or produced by Smartbox, which I've shown you before, but I can quickly show it again. And the other sort of first for the ear switch is control of environmental controls. And we've done this remotely with the help of Function Control and Nick's system to his workshop. So we've been doing that remotely, and I can show that as well, hopefully. The thing that has been a bit of a problem is integrated with Tekla. Now, Tekla is a fantastic bit of kit. It's approximately sort of 7 centimeters in a square, a black box, looks great, and it acts as a central switch interface for all sorts of existing technology. So we weren't trying to replace what was already there. We just want to be a front end, a very simple front end switch to control all these fantastic devices already out there. So we've finally managed to do that. That's been a bit of a headache, and first thing this morning, Thomas was successful. Yeah. So if we switch now to the probably the setup on screen. Oh, if you come to us then, Thomas, so that we can show the ear switch.
Hello.
So we're back on. So we can get function control showing.
I don't think the function control aren't quite here yet. Okay. So we'll be able to show their.
Okay, should we show the other one then?
Yeah, we'll show whatever. So hardware limitations. We didn't quite have the right hardware already, so we had to hack together a basic solution of the integration between my code, which detects the movement and sends the output, and the Tekla. So we'll just put that down on the screen now. So it's very hacky, but it works. And the whole point of this event is to hack solutions together to prove that they have the capacity of working. So here, this black box thing is the Tekla device, and it takes a simple audio jack input as like a a current passes through, and if basically the regular accessibility switches would close that circuit and send a pulse to the Tekla, activating one of its potential switches, and allow you to control a phone with it. So the Tekla itself is a button itself. So if I were to push down on Tekla and everything's connected properly, and
We set up for the scanning.
we live demos, everybody, live demos. Is it connected? We swear it works. Here we are. Now it's connected. Now it's connected. He says, hoping it works. Apologies, we're having technical difficulties.
The advantage with the Tekla is it can actually connect with multiple devices. So that's actually an advantage for the Tekla itself. So it can switch between different devices to control. So like your mobile phone, your iPad or things like that. But the disadvantage for us is it might be connected to something else. So it is connected to mine, so that's perfect. And so if we set up switch access again, so the trouble with these things is obviously once you know how to do them, it's fine. But when you're still learning, it takes a bit of time. So
here we are. So now it's working.
Okay.
And if I can wait for the thing to scroll back, I press the button and it activates the switch access. So if we go back into the Tekla app, can activate this, and our lights are currently enabled with the function control set up. Though I'm not getting quite the right output from this, unfortunately. Not sure what's going on. But that's how Tekla should work in theory. And now I think we'll test with the ear switch capabilities. Sorry, live demos are always a nightmare, everybody. Bear with us.
I don't think we can show me and the interface at the same time. Those things. So you have to just believe me that I have. Has that worked or not?
No, you got to press it up.
Yeah.
Hold on. Up arrow.
Yeah. Turn.
Up again.
No, it's not showing.
There.
Okay. So it is picked up. It has. Okay. Well, I think we'll have to leave that.
We'll have to leave.
So we'll come back to the. If we come back to the screen.
There.
And before we've shown you the Grid 3 software. We've looked at other functionalities with the Grid 3. But we've also the other thing we've learned a lot is how actually Grid 3 is very configurable. It's got lots of different functions, and I think the problem with these things is actually they are so good until you become an expert user, you don't quite realize how good they are. So if we look at computer control, I think we showed you this before. What we can do, and I'm not going to do this with my ear at the moment because I need to rechange a session, is what we've found is that these buttons here are a lot better for controlling the keyboard, and so we can actually control just with a simple key click. We can show where the mouse is going to go, so that's just one key, and it will actually allow us to move the mouse around with a crosshair or the radar, and the radar will let us stop at various different places and click. And we click again. So so not as neat demonstration as you had last time, which was a bit of a shame.
Yeah.
I also wanted to show you if you can just bring it onto the camera onto the board as well. That I'm slightly mourning, and my my smallest camera died last night, and that was the most recent iteration, which sat very nicely in the air and didn't move at all. But there you are, things never go to plan. So I wasn't designed to be on Blue Peter. So I think we've been successful in that we've shown that we have. We've managed to confirm that it is possible. Should we go to the? It is possible to communicate just with the ear switch. So this collaboration, I think, has been really successful. It's brought together people with similar interests but coming from different aspects. And really, future work is collaboration between all the partners: Heriot-Watt University, University of Bath, Function Control, Smartbox, and Tekla, to come up with the next stage of a dedicated switch. A plug-and-play control for all assistive tech, so it's actually going to be a simple front end, and to sort of produce a package of proven technologies together to say to users, we know it integrates, this is easy to set up, and ultimately enabling a better life. So my last plug is, if you can help us, because we still need to validate this with the National Institute for Health Research funded research work with Bath University. You can go to earswitch.co.uk and fill in the survey. I will leave that plug. I'll see if Thomas has got anything else to add. Unfortunately, we don't have Nick with us from Function Control.
Yeah. Sorry about the demo not working. Please believe us. It does work. I'll just swap back to us for now. Yeah, it does work. We've proven that you can control device like accessibility devices and accessibility softwares with a device like the ear switch. The next step is to be turning my clunky but workable code into a more refined, dedicated device with a camera attached to it, so that it's all one secure thing, and work on the wireless communication aspects and hopefully just improve in general on the speed of the detection and all of that. So I think the product is great. With some refinement, it could be a fantastic quality of life improvement for lots and lots of people.
I think we have to tell Alan we're done.
Yeah.
Anyway,
thank you very much for watching our progress this week. I'm sure we'll stop being live shortly. Yeah.
Hi, folks. Welcome back. The bit you've all been waiting for, where we announce the winners of the Robotics and Care Mashup. I just want to say a huge thank you to all of our participants, all the hard work that they put in this week. This whole event's been something of an experiment for us. It's definitely a challenge running these kinds of things remotely. But we've been really delighted with the engagement and the progress that the teams have made, and all of the people that we've been able to bring together. A huge thank you to our sponsors and all our mentors. So thank you to the Usher Institute, to Shill, to Robert and his team for all the mentoring they've done this week, and obviously to our partners, the Robotarium and the lab here. So one of the things that we wanted to say, wanted to offer, it's been such a shame that we haven't all been able to meet up. But as things open up this year, we'd like to invite all of the teams, all of the participants to come up to Heriot-Watt, spend a day here in the lab, get to meet Pepper and the wee dog. He's a wee dog. Miro, and so get to meet all the robots and have a day of hacking and playing here in the lab, and we're able to do that. For the winning team, we'll be paying any transport costs up to Heriot-Watt in order for you to get here. So don't know exactly when we'll be able to do that, but we'll do that. Normally, when we announce our winner at Product Forge, we hand over a complimentary bottle of champagne or something. We can't do that, so it'll be a virtual bottle today, but we'll certainly be buying you drinks when you can come up to Edinburgh. So with that, I'd just like to hand over now to our three judges to talk about to announce the winners for this event and their feedback. So Chow, Michael, and Robert, take it away.
Thanks very much. Can you hear me okay?
Yeah, okay, Chow.
Yep, I'm my 1-year-old has just started nursery, so I'm right in the middle of the first of many colds. So apologies for if I seem a bit lackluster. It was a great range of presentations and demos there. Thank you very much for that. I've been to quite a few hacks in my time, and you usually see quite a bit of overlap, as everyone's trying to tackle the same kind of problems. But I think uniquely, each and every one of the pieces had a completely different slant on the kind of problems we're looking at. So that was quite good to see, just the kind of breadth and quality of the submissions. So for us, the winner of this round was Hermes. And I think we were keen to just sort of also say that Curio were a kind of close runner-up. Maybe pass to the other judges to give a little bit of additional feedback, if that's okay.
Yeah, thanks, Charles. Just repeat Charles' comments about it's really good fun to be involved in these hacks. There was one last year at Product Forge round, and they're really always exciting to see all these ideas come through. And all the work people are putting in. So thanks very much for the presentations. They're really interesting. We had a really good chat about them. The feedback on Hermes, for me, I think the underlying factor across a lot of these innovations in health and social care is one of the big challenges, certainly for us, is bringing the human aspect to the tech and the human aspect to elements of robotics. And I think we thought the Hermes software development potentially provided a next step, a step change into bringing that aspect of how you bring the more sort of subtle human, emotional, and cognitive essence to some of the communications that happen through tech. We're all very used to virtual sitting like this the last year, but actually, so people are very used to now. It's been forced to do it over the last pandemic, but actually being able to bring that to much more applications. So, for example, some of the applications that were presented, if you could apply that level of software and that human aspect to some of those interactions, you could take those to the next level as well. So we thought Hermes provided that more universal step in terms of a fit across a range of products. But it was a close run thing. And I think Robert's going to provide some feedback on Curio.
Sure. Yeah. Thanks, Michael. Chal. Again, just to reiterate, I mean, the standard was really, really high this year, as ever, and there's some fantastic pitches there, some fantastic presentations and ideas. I think Curio, we really liked it. I suppose the the difficult thing with Curio, the risky thing, is always going to be the cost and the acceptance of having robots like Pepper in your house. I suppose one thing we did think of, though, and this relates to the Hermes idea as well, eventually we are going to run out of humans to actually deliver this sort of care. And while that might be a limitation for Hermes, it could be a benefit for Curio. So actually combining some of the aspects of the two could be an interesting way to do it. The other presentations, yeah, we love those too. I mean, what I would say about the false detectives, I think maybe the concern we had there really was it's such a saturated market, and it is quite a difficult one to get into, and there is a lot of potential litigation. If you fail to detect a fall and somebody lies there for ages and dies, I guess one suggestion perhaps for that team is to take what you've got, but think about more falls prevention, which would be easier to get into and could be equally valuable. The same with Hivebot. I mean, we really like the idea of having these different robots talking to each other in the house, and that's something that is quite novel and innovative and hasn't really been done before. And I guess for them, we would say, well, explore that, but also explore potentially using sensor technology to a greater degree to see if you can drive it forward that way. I don't know if Chal or Michael, if you had any other comments for the other two teams there, or things you want to add on.
I guess, yeah, just to echo your last piece on the kind of, I guess, the kind of networked approach with multiple robots. I maybe didn't, my feedback in the Q&A probably wasn't as good as it should have been, but yeah, no, it's just there's a thing here where there's a danger of us focusing on robotics and thinking about the entity that is the robot and then putting it into a completely unequipped house, when the reality is, if you've got the connectivity to make a robot work well in a home setting, the chances are you could have some passive ambient sensors, and the home itself is going to be more intelligent. So I really like the idea of multimodal. So yes, have companion robots, yes, have roaming robots, but the chances are that house in 5-10 years time is going to have an automated vacuum cleaner and a smart meter. And a range of other bits and pieces. So it'd be really interesting to explore how robotic companions and other components actually interact with that broader piece. And we did reflect on some of the Falls Detectives kind of home hub, the kind of open home hub, and how ultimately creating that open source infrastructure that could sit in the home and have multiple services applied across it and work across those different smart components. Ultimately, that's the big prize. If we can get into that space and not be beholden to proprietary technologies for the actual exchange of information within the home, then that would be very welcome. So we did like that bit, and we got quite keen to see more of that in the future. Thank you.
Great. So thanks so much. Is there any other kind of closing remarks you guys like me to make before we wrap up?
Just one final thing, I was picking up what Robert said earlier about the falls and building on Charles' stuff. I mean, I think as well as the human factor in robotics, I think the big focus, I think, in the future will be prevention and prediction. So anything which looks and tries to predict and prevent activities before they happen, to offset that decline and to delay that need for intervention, then that's the real sweet spot, as well as bringing that sort of more human aspect to that.
Great. Okay, well, thanks so much. Thank you so much to Chal, to Michael, to Robert for your feedback just now. Well done to all of our teams. Well done to our winning team. I'm going to hand over to our newly minted TV star, Maro, who's been absolutely loving getting in front of the camera and doing all of this. You can see his face lights up as soon as I put a camera on him. I just want to obviously say a huge thank you myself to Maro for inviting us into this project. It's been wonderful being based here at Heriot-Watt. This is the first time we've done a virtual event. This is the first time we've done anything with so much of a hardware focus. And it's been fantastic to see all the resources here. So for my part, I've really enjoyed it. It's had its challenges, but I can't wait if we can get everyone up to Edinburgh, everyone up to the lab to have to meet them all face to face. So well done again to everyone. It's been a long week. There's been a lot of work put in. Our model team's been hacking away in the background here, working late nights. I know it's been exhausting, but hopefully rewarding for everyone. And I don't know when we'll see you, but hopefully see you soon. thanks to all of our sponsors. Thanks to Shill. Thanks to the Osh Institute. Thanks to the Robotarium. And I'll leave you with Mauro to say our closing remarks.
Thank you very much, Alan, for all your great work. Thank you very much, Robert, Charles, Michael, for all your help. Congratulations to the teams, especially Hermes, the winners, and Curio, the runner-up, but also the other two. I second what the judges said. All the teams did great work. I hope everyone enjoyed the learning experience. So special thanks to the Scottish Health Innovation and all the mentoring organizations, including the Scottish Social Services Council, Census, all the people at the Digital Health and Care Innovation Centre who helped us also to run some co-design workshops before the Mashup. And again to the co-organizer, the Usher Institute and Design Informatica at the University of Edinburgh. Special thanks to all the speakers. We had a mix of very interesting talks. I think we generated a very nice set of great presentations, and I think Alan will put them online, so they are being recorded, and they will be a testimony of what we have done at in this event, where we tried really to combine, to put together a mix of very heterogeneous people, students of all levels. We had undergraduate students, we had master students, PhD students, working with professors, healthcare professional, organization providing health support. So it's great to see an event like that with the help of Product Forge, Alan, and we like from the National Robotarium to do this again, to learn from this experience and to grow it every year. Thank you very much, everyone.
And just to add, just at the end here, if the community hub isn't going anywhere, it's still going to be online. So you can still get in touch with the organizing team, with the other community members, with our sponsors and partners, and of course the teams who have been participating through that hub. So hopefully that will stand as a fantastic resource in the time ahead. So.
Yeah, we'll communicate something to the hub to gather the feedback from the community. We know that things on the platform were not as smooth as we liked, but we'd like to receive your feedback so that we can improve next.
Brilliant. Well, normally I'd invite everyone up onto the stage to wave goodbye, but we can't do that today. But goodbye for me, goodbye for Mauro. We'll do our breakfast TV bit. I'll see you.
Thanks, Alan. Thanks, Mauro.
Thanks a lot.
Thanks a lot.
Cheers.
Cheers.
Thanks, everybody.